I'm Satya, Assistant Professor, Department of Computer Science from KC's Cosinodal College of Arts and Science. Now we are going to see the important topics of system calls, system structure in operating systems. The topics that we are going to cover is system calls, system programs, and the system structure. What do you mean by system calls? That is, during the time of running a program, the operating system and the program maybe have an interface. At that time, they may be exchange the messages that is known as the system calls. It's generally available as the assembly language instruction only. The language is defined to replace the assembly language for system programming, allow system calls to be made directly only. Three general methods are used to pass the parameters between a running program and the operating system. The parameters may be in the registers. The parameters in a table of memory, and the table address is passed as a parameter in the registers. Then the stack is used. The stack is a data structure. Push the data means we are adding the data. Pop means we are deleting the data. Push the parameters onto the stack by the program. Pop off the stack by operating system. This is the example of passing of parameter as a table. Here, X is a register and it's contain the data. The program passed the data in the register X to the operating system. It is done by the system calls. Okay. From that, it's take the address. From the address, it may take the data during the time of executing. There are so many operating systems. The first one is the MS-DOS. DOS means Disk Operating System Execution. Here, the system calls can be done as here. It's a memory location. Here, kernel is the center core of the operating system, and command as well as the interpreter are used for execution. And process means that is the program that is in execution, and free memory. Free memory means the memory is not used. A system startup, during the time of starting a computer, the process may not be available. And during the running a program, the program that is in execution is process that is loaded into the memory. This is the difference between the startup as well as the running a program in memory. In Unix, running a multiple programs. Unix is a real-time operating system, so it may run more than one program at that time. Here, the processes are differentiated as process B, process C, and process D. Intermediate, there are free memory, interpreter, as well as the kernel. Kernel is operating system. It's always be resident in the main memory. And interpreter is a system programs that may be used for executing a program. Free memory, the free memory is for another program for allocation. Communication model. The communication models means the data is transferred between the operating system as well as the processor or between the processor. Message passing. Message passing means the message is passed between the program, that is the process, and the operating system. The operating system may give command to the process, or process may request some information from the operating system. These are the message passing. And shared memory means two processes, two programs execution may be in execution, and it start the memory for the execution. The shared memory is located in between the process A as well as the process B, and two of the processes may be shared the data during the time of execution. The kernel is the operating system. It's reside in the memory forever. System programs. The system programs is a convenient environment of program development and execution. There are so many system programs: file manipulation, status information, file modification, programming language support, program loading and execution, communications, applications program. The program that are developed by the user is the application program. The remaining all the things are handled by the operating system. Most user view of the operating system is defined by the system programs, not the actual system calls. This is the user view. System structure. So many structures are there. The simple approach is the MS-DOS structure. It is written to provide the most functionality in the least space. It's not divided into modules. Although MS-DOS has some structure, its interface and levels of functionality are not well separated. Here, this is the MS-DOS layer structure. Here, RAM BIOS device drivers, MS-DOS device drivers, resident system programs, and applications programs. Some of the system programs may be loaded defaultly, that is in the resident system programs, and MS-DOS device drivers. That is the device drivers via that the data can be passed. ROM bias device drivers. Here, the read-only memory, that is the basic input-output systems are stored here. The application program have direct connection with that for the execution. System structure, it's continued here. Unix, limited of hardware functionality. The original Unix operating system had limited structure only. Unix OS consists of two separate parts. One is the system programs and the kernel. These two are stored in the operating system. Kernel means it's consists of everything below the system call interface and above the physical hardware. Provides a file system, CPU scheduling, memory management, and other operating system functions. That is large number of functions for one level. This is the Unix operating system structure. Here, in last we are having the hardwares, that is terminal controls, terminals, device controllers, memory controllers, all are hardwares. Above the hardware we are having the kernel interface to the hardware. The kernels are here. It maybe get interface with the hardware during the time of some execution. And above that we are having CPU scheduling, file system, signal terminaling, all the basic needs for the executing a program, and system call interface to the kernel. Here only, in the system call interface to the kernel only, via this the program communicate to the operating system. Beyond that, cells, commands, compilers, interpreter, and system libraries, all are the system programs for the execution. Finally, we are having the user. Here the applications programs are stored. In layer approach, before that we have seen simple approach, now layer approach. The operating system is divided into a number of layers. The layers are known as the levels, each built on the top of the lower layers. The bottom layer is marked as layer 0 in the hardware, and the higher layer is marked as layer N in the user interface. That is, user means applications programs. With modularity, the layers are selected such that each function and services of only lower level layers. Here, this is the operating system layer approach. Here, the layer, top one is the layer M, and below we are having the layer M-1, that is start from the layer 0. Some existing operations may be there. The new operations are stored in the top level layer M, and some of the operations may be hidden operations. That is, the operating system is a hidden only. Likewise, the system programs are also the hidden one. The lower level layer approaches may be the secured purpose, and it may be hidden for the usage. In layer structure of the OS, the layers are stored like this only. The layer design was first used in the operating system. There are 6 layers here. The below layer 0 is the hardware. Next, CPU scheduling, memory management, operator console, device drivers, buffering for input and output, and finally the user programs. Hardware is the basic things. From that, the CPU scheduling. CPU means central processing unit. It's scheduling the number of program that is waiting for the execution. Among the waiting process, it may select any one of the process based upon the scheduling algorithm. Memory management. Memory management means there are so many spaces, free spaces in between the allocated one that is not used. The memory management free up that spaces and move into one side for the usage. Likewise, the layered approach is stored in the operating system. This is the layered approach. Here, there are 4 device drivers. All are the hardwares. It may be the networking system or any pen drive system or any keyboards, etc. And system kernel. Next is system kernel is the operating system. It may do the work, memory management, disk scheduling, device management, all the works are done by the operating system. And next we are having the subsystem. Subsystems we are having the system programs, that is the compilers, interpreters, anyone. And then application program interface. Interface is the space where one person may connected with the other person. The application program interface is used to connect the application program to the kernel. Via this only the application program can communicate to the operating system. Application programs are the programs created by the user. So we can say via this interface, the user program can communicate with the OS. In top layer, we are having three applications programs are there here for the execution. Thank you.